Okay, now we're going to look at electrophilic addition to an alkene by bromine by Br2. So you let's draw ethene to start off with. Right, we did the mechanism of the reaction with HBr before. I may be a little bit surprised here talking about electrophilic addition by Br2 because of course there is no permanent dipole in that molecule, is there? Because the bromines obviously got the same electronegativity. So what happens here? Well, there isn't a permanent dipole, but what happens? You get an induced dipole, okay, which you have heard about before. We're talking about van der Waals forces, right? So what happens is this end of the bromine, it will become delta positive, and that will become delta negative because you've got a load of high electron density there, haven't you? So what's that going to do to the electrons in the bromine molecule? It's going to push them all down this end, and it's going to create an induced dipole. So that's why this will react, and then the reaction is exactly the same as we've done with the HBr. What happens is as this bromine gets closer and closer, it will attract the pi electrons, and they will eventually jump onto the bromine and form a sigma bond to the bromine. And then this bond will simultaneously break, so those electrons will shrink back and form a lone pair. Instead of a bonding pair, form a lone pair on that bromine. So we draw the intermediate there. We're going to have H, and then we've got a bromine attached to this carbon now. And this one has got two H's, and we've got a Br minus ion there. Right, now there must be a positive charge on this, yeah. We're talking about our conservation of charge, yeah, because we've got a negative thing there, so there must be a positive on that. Where is the positive thing? If you remember from last time, the positive charge is on this. This is called a carbocation. It's on that carbon there. Carbocation, intermediate, very reactive, only lasts for a fraction of a second. And then that is going to react with the bromine. So that there's four lone pairs on the bromide ion. I'll just draw one of them, and that's going to go onto that, and so you're going to produce the final product, which will be 1,2-dibromo ethane. Okay, and this of course forms this is the test for a double bond. Okay, test for a CC double bond, which you've known about since GCSE, and it will decolorize bromine water. Bromine water, of course, is red-brown, and it forms, it loses its color because the bromine is gone. Okay, just while we're here, and it's quite a short video, so let's just talk about here. If you do this reaction, if you do the reaction in the presence of chloride ions, okay, so if you add some sodium chloride or whatever, well, what happens is you will get some product. You will get some, because of course the chloride ion could quite easily react with the carbocation, just as, and you'll get some of that will be produced. You'll also get some 1,2-dibromo, but you will not get any dichloro, and that's the sort of indirect evidence that this reaction does occur via a carbocation intermediate. The fact that you can't get any of the dichloro because the chloride ion obviously can't react with alkene because it is not going to be a good electrophile. It's got a negative charge. It's going to be repelled by that, isn't it? It's only going to be reacting with the carbocation. So you will get some of that, but you won't get any of that. Okay, so that's a nice short video. I'll just do one more electrophilic addition reaction in the next one.